Estrogen and progesterone are the female sex hormones, and they're produced mainly by the ovaries, the female gonads. The female body can synthesize 3 types of estrogens: estradiol, estrone, and estriol. Of the 3, the ovaries synthesize estradiol, which is the most biologically active of all of them, and accounts for the majority of sex-specific changes that begin in puberty, like monthly ovulation and menstruation, as well as the development of secondary sex characteristics. Small amounts of estrogen are also produced by the adrenal cortex and fat cells and adipose tissue, and the placenta secretes these hormones during pregnancy as well. But during the reproductive period, it's the ovaries that produce the majority of estrogen and progesterone in the female body. Before puberty, the hypothalamus secretes small amounts of a hormone called gonadotropin-releasing hormone, or GnRH. Then GnRH travels to the nearby pituitary, which secretes 2 hormones of its own: follicle-stimulating hormone, or FSH, and luteinizing hormone, or LH. Once puberty hits, the hypothalamus starts to secrete GnRH in pulses, sometimes more and sometimes less, and FSH and LH make the ovarian follicles develop and secrete hormones. The ovarian follicles are scattered throughout the ovaries, and each ovarian follicle is made up of a ring of follicular cells surrounding a primary oocyte at its core. As the ovarian follicles develop, the follicular cells differentiate into theca cells and granulosa cells, which both play a role in the synthesis of progesterone and estrogen. How much of these hormones is secreted is directly related to the phases of the female menstrual cycle. The menstrual cycle lasts 28 days on average, and is centered around a surge of FSH and LH happening on day 14, which makes ovulation possible. The variations in FSH and LH levels result in fluctuating levels of estrogen and progesterone that vary according to the phases of the menstrual cycle. 2 weeks before ovulation are called the follicular phase, during which mostly estrogen is produced. The 2 weeks following ovulation are called the luteal phase, during which progesterone is the dominant hormone. During the follicular phase of the menstrual cycle, estrogen makes the superficial layer of the uterus, the endometrium, thicken up and spread progesterone receptors. During the follicular phase, estrogen acts as a negative feedback signal, making the pituitary secrete less FSH as estrogen levels rise. Right before ovulation, the really high estrogen levels make the pituitary much more sensitive to the actions of hypothalamic GnRH, and so they turn into a positive feedback signal, leading to a massive surge of FSH and LH that leads to ovulation. During the luteal phase, progesterone binds to receptors in the endometrium and stimulates the endometrial glands to produce more secretions that prepare the uterus for a potential pregnancy. Progesterone acts as a negative feedback signal during the luteal phase, making the pituitary secrete less LH. And in turn, the levels of progesterone decrease as well, and menstruation follows. But estrogen and progesterone are steroid hormones, so their production starts with cholesterol. Cholesterol reaches the theca cells, and inside there's an enzyme called cholesterol desmolase, which converts cholesterol to pregnenolone. Another enzyme in theca cells, called 3-beta-hydroxysteroid dehydrogenase, converts some of the pregnenolone into progesterone. However, most of the pregnenolone is converted into 17-hydroxypregnenolone, and then into dehydroepiandrosterone, or DHEA. 3-beta-hydroxysteroid dehydrogenase is quite the overachieving enzyme, because it also acts on DHEA and converts it into androstenedione, a testosterone precursor. Androstenedione diffuses into the nearby granulosa cells, which have two enzymes of their own. The first is 17-beta-hydroxysteroid dehydrogenase, which converts androstenedione into testosterone. And the second is aromatase, which converts testosterone into 17-beta-estradiol, the most biologically active type of estrogen active during the reproductive period. FSH makes aromatase work overtime. So, during the follicular phase, a whole lot of 17-beta-estradiol is then released into the blood, where it's bound to a plasma protein called sex hormone binding globulin, or SHBG. That carries it to the nearby target tissues, such as the uterus and the vagina, and to other cells and tissues in the body, which respond to estrogen stimulation, such as the bones and the blood vessels. And finally, something interesting happens inside the granulosa cells during the luteal phase. They respond to the low luteinizing hormone concentrations that are present after ovulation by increasing the activity of another enzyme called cholesterol side-chain cleavage enzyme, or P450-SCC for short. This enzyme converts granulosa cell cholesterol into pregnenolone. What's more, granulosa cells also have some 3-beta-hydroxysteroid dehydrogenase of their own to convert the pregnenolone into progesterone. So, during the luteal phase, granulosa cells secrete more progesterone than estrogen. Progesterone is then released into the blood, bound by plasma proteins like albumin and transcordin, and transported to target tissues. Now, both estrogen and progesterone have local effects, meaning that they act on the organs and tissues nearby, as well as systemic effects, meaning on the rest of the body. Starting with puberty, estrogen and progesterone are responsible for maturation of the female reproductive organs, the fallopian tubes, the uterus, the cervix, and the vagina. Estrogen is also responsible for female secondary sex characteristics, with growth of breasts and the widening of the hips, as well as distribution of fat on the buttocks, hips, and thighs. On a systemic level, estrogen has a protective effect on the cardiovascular system, helping keep the blood vessels wall flexible to accommodate blood flow, as well as the skeleton where it helps sustain bone density. Estrogen also protects against cardiovascular disease by lowering levels of LDL cholesterol. Progesterone, for its part, also plays a role in bone strength, as well as in keeping the skin elastic. Now, during pregnancy, the placenta takes over estrogen and progesterone secretion, both of which are required to maintain the pregnancy. But there's a twist. The placenta produces estriol rather than 17-beta-estradiol, so that becomes the dominant type of estrogen. During pregnancy, estriol and progesterone also help prepare the breast for lactation after delivery. Another plot twist occurs during menopause, which usually happens around age 50. At that point, the ovaries run out of functional ovarian follicles, so there's no theca of granulosa cells to produce any more hormones. This leads to a decrease in estradiol levels, accounting for many of the symptoms preceding menopause, like hot flashes and night sweats. But some estrogen is still being synthesized by the adrenal glands and the fat cells in the menopausal woman's body. However, these tissues produce estrone, so after menopause, estrone is a dominant kind of estrogen. Alright, as a quick recap. Estrogen and progesterone are the main female sex hormones, and they play a crucial role starting with puberty. During the reproductive period, granulosa cells secrete estrogen and progesterone. During pregnancy, the placenta secretes estriol and progesterone, and after menopause, Small amounts of estrogen are produced by the adrenal glands and the fat cells.